Okay, so we will going to see about the boost converter. It is a very interesting topic. Boost converter. First point I will tell you what is a boost converter. Input is a 50 voltage. Output is a 100 voltage. Output is high compared to the input voltage. Output is a high compared to the input voltage. That is called the boost converter. That is the point number one. What is the boost converter? I will going to repeat. Output voltage is a greater than input voltage, output voltage, so greater than v naught. So v naught is a greater than vs, v naught is greater than vs, that is called a boost converter. Output voltage is greater than the input voltage, output is high. So here is a 50 voltage means output is 100 voltage. How it is a possible? Very simple. There are two mode of operation. What is the two mode? One is switch is closed, the second one is a switch is open. That's all, very simple. Mode 1 is switch is closed, mode 2 is switch is open. How 100 voltage is produced? You are apply 10 voltage, but output is 100 voltage. How it is produced? Very simple. So you are going to apply the mode 1 condition. So 50 source is a constant 50 voltage. Okay, first one, switch is closed. Switch is closed means diode is open. Okay, switch is closed, diode is open. Okay, so when switch is closed, this is a path. Okay, this is a loop only closed. Okay, the current is not flow to the load. Why not flow? Because the switch is open here. Diode switch is open. Then what will happen? Current is start to flow from the source to the source to the L to the switch to the closed circuit. Note down the path. Source V, okay, VDC, okay, Vs plus, so Vs plus, then L to the switch, CH I will going to write, and switch to the Vs negative. So during the mode 1 condition, the source is a flow, the source is a go to the load? No. During the mode 1 condition, source is not flow to the load. Why not flow to the load? Because diode is switch is a open. Okay, fine, good. So this is a not flow this side. Okay, so only this is a loop only closed. So during the loop condition, what will happen? Inductance get the charge. So inductance get the charge. It will going to getting the charge on that 50 voltage. For example, direct 50 voltage. So 50 voltage is getting the charge. 50 voltage is coming to the inductance. Mode 1 is over. So mode 1 inductance is getting charge. What about mode 2 condition? The switch is open. Okay, diode switch is closed. Okay, during the time what will happen? Source is a flow. Okay, through the inductance to the load. Yes, it's a like it will going to flow. See that one. So this is a path. Write the path. Vs plus and the inductance to the diode, and the diode to the load, and the load to the Vs negative. Write down the path. So you will going to get the mark. That's all. So write the path. So yes, it is a flow. So what is the voltage of the input source? 50 only. Then here is a 150, inductance is another 50. So totally two sources flow, one from inductance, one from the source. Okay, 50 plus 50 is equal to 100. 100 is going to the load. That's why output is 100. So during the mode 1 condition, inductance charging. During the mode 2 condition, inductance getting discharging. So 50 plus 50, 100 is a flow. If you have see that a diagram mode 1 condition, inductance is a plus with respect to minus, charging. Here minus with respect to the plus, discharging. It is a discharging. That's all. This is a method about the two mode conditions. Why output voltage is high. Okay. Then if you have see here is a mode 2 condition equation. What is output voltage? Vs input source plus what is this one? Inductance source. What is the inductance source you are representing? So this is a inductance source is representing inductance di by dt. Vs plus another one. So this plus this. Okay, fine. Okay. Then so this is about the waveform. Okay, waveform about that one. We're going to show about the waveform. So on period. So during the on period, what about that inductance? It is a charging. What about off period? It is getting the discharge. It will going to get the discharge. So during the on time, it's a getting charging. During the off time, it will going to get the discharge. Off time, it will going to get the discharge. When output voltage is present, so during the mode 2 condition only output is present. Why mode 1 condition not present? Because mode 1 condition totally isolated. So So here is only close, this is open. So total load is isolated from the source, both source it is isolated. So that's why what happened, so this mode 1 condition output voltage is 0. During the mode 2 condition only what will happen, two sources coming, one is input source, another one is inductance source, two sources coming. So due to the two sources, the output voltage is high 100 voltage. So like it is a producer, that's all. So output voltage current waveform and output current waveform also during the mode 2 conditions. Okay, so it's on period, this is off period, it's a combined, it is called total time period. It's a combined is called a total time period. That's all. This is about the boost converter, or another name it is called a step up converter. And one more interesting, so this boost converter it is used to, okay, here equation the same. What is the equation? So output mode 2 condition, what is the mode 2? Switch is off, yes or no? The switch is off in the mode 2 condition. So during the condition, what about output voltage? This is output voltage. Output voltage is equal to input voltage plus inductance voltage. The same thing is written. Okay, so Vs plus VL simply I have written. Okay, this is VL only you want to write, means Vs V0 minus Vs you will going to write. Okay, so coming to that one more important. Okay, there is a power wise call differentiation. Just you can look it. It's very simple. You will going to understand about the power, input power, output power. Okay, no losses. Input power is equal to output power. Then this is the equation V0 is equal to Vs into T on plus T of T. And then this is further you can simplify and get the final equation. V0 is equal to Vs divided by 1 minus alpha. 1 minus alpha. So you will go to alpha is a firing angle or delay angle. Then if for example alpha I will go to apply the 0, or alpha I will go to apply the 1. What about the output voltage? What about the output voltage? So it will 0 to 1. What about the variations? They will going to return. I will coming back to you later. So if you have look, it is easy to understand. So coming to that one, this is I want to come make regeneration braking is possible. How regeneration braking is possible? Regeneration, for example, now the electrical vehicle is famous everywhere. They are talking about the electrical vehicle. So whenever you will going to apply a brake, so what they are saying, whenever they will going to apply a brake, regeneration is possible. How it is a possible means the torque was changed, the torque polarity was changed in electrical vehicle. That's why regeneration is possible. So coming to the point, easy to understand. Do you know hills place? What is a hills place? So like this is a hills. So during the hills place, what will happen? The vehicle is moving from the bottom to top. Yes. So like it is a vehicle is moving. So it is called motoring action. Motoring action means synchronous speed is less than this. Okay, sorry. Motor speed is less than the synchronous speed. Motor speed is less than the synchronous speed. Synchronous speed is 1500 means, so always 1500 below only. For example, motor speed is, what is that one? It will maybe 1000, because see 1000. What about that one? 1500 is always higher. 1500 is always higher. 1500 is always higher. So because see how struggle move from the bottom to top. Yes, the motor is move from the struggly, okay, move from the top bottom to the top, more struggle. So always synchronous speed is motor speed is always less than the synchronous speed, it will less. But once it is the vehicle is coming to here, the vehicle is coming, what about the speed now? It's a top to the bottom, it's a top to the bottom. What about the speed? Now rotor speed is a very high, so rotor speed is greater than the synchronous speed. Synchronous speed is 1500, but now rotor speed is a 2000. Now rotor speed is a 2000 rpm. Okay, and compare with the synchronous speed 1500. So whenever that rotor speed is higher than the synchronous speed, it is act as the generator. It is act as the generator. Okay, it is act as a generator. Just this is one concept. Coming to here, okay, like the regeneration braking is nothing but that is only. So what that is called the regeneration braking. So what is a regeneration braking? Okay, so here, okay, so you will going to use for that motor load. So motor load you will going to use. Load is what type of load? Either RL load you can use, or motor load I will going to use. Motor I will going to use DC motor. Okay, DC motor I will going to connect it here. So what is motor? So if I will going to connect it, so during the mode 1 and mode 2 condition, what will happen? My motor output voltage is 100 voltage. Input voltage is a 50 voltage. Okay, who is a higher? Output is higher. Output is higher. Whenever output is higher, okay, because of the motor load, output is higher. So now regeneration is possible. Now regeneration is a possible. Regeneration means it's a start to flow this directions. So this is called class B. This is called class B. Now directly we'll go to the class B. Class B, what is it? Where is a class B? Yes, this is a class B. So I will coming directly here, class B. How many quadrant? Only one quadrant. Only one quadrant. Which quadrant? This is called the second quadrant. Second quadrant. What is the quadrant name? Forward braking. Why it is called forward braking? Because output current only changed. Output current is only changed. Output voltage is not changed the polarity. So forward directions. Okay, current only changed. That's why forward braking. Why it's a braking? Current polarity was changed. Why current polarity is changed? Because load to the source. Now current is a flow from load to the source. Why? How it is a flow? Because load is 100 voltage. Load is 100 voltage. Source is a 50 voltage. So who is higher? He is higher. Load is higher. What type of load you are using? Motor load is used. Load to the source, it is a flow. So that is called a regeneration braking. During the regeneration, you will going to charge the battery. Like you are going to electrical vehicle, you are studied. During the regeneration, charging the battery. How it is a possible? Because the hills place, the vehicle is moved from the top to the bottom. Okay, it is a act as the generator. So due to that one, it is a energy is giving. So that energy will going to store the battery. So very simple. Okay, don't think about first point. It's a class B. It's a forward braking. What is a class B? Class B is a step up chopper, or another name boost converter. Why it is called a forward braking? Output voltage is positive, but output current only negative. Okay, that's why it's a forward braking. Means output current is negative. Why it is negative? Load to the source. That's why negative. Okay, coming to that one, class B diagram. Yes, class B diagram. This is a class B. See there. Okay, so this is about the class B chopper. So this is a quadrant about covered. Okay, previously what is the diagram I have to draw you? So first one, okay, inductance I have draw you. Okay, yes, inductance, switch, and a switch followed by diode. Yes, so this is only you have draw about the boost converter. Yes, so inductance, switch, and diode. This is called the boost converter. The same. So previously here is applied as a source. Here I have applied as a load. Yes, that is a boost converter. So far discussed. So now what will happen? So my load is 100 voltage. So here I will going to connect it as a 100 voltage. So here is a, so now load to the source. So see coming here, what is that one? Inductance is present, and inductance followed by here switch is available, then diode, then source. So this is a method, it is a flow. Okay, so see, so previously boost converter, just I will going to draw here. This is a, this part is considered as a load. That's all. This part is considered as a load. This part is considered as a source. Why? Because it's a, now it's a my turn. It's a my turn. Why your turn? Because my I have 100 voltage. I have 100 voltage. You have only 50 voltage. So it's my turn. So my turn. I want to give back to you. Give back to your load to the source. How? So it's a, as it is also same. Okay, here is a 100 voltage available. See that one, inductance, switch, diode is there. Source is here. Okay, here is 100 voltage. Here is a 50 voltage. So mode 1 condition. Okay, switch is closed. So as well, what will happen? This load, it will going to give the energy to the inductance. Give the energy to the inductance. Okay, 100 is, it is positive the 50. Okay. During the mode 2 condition, what will happen? The switch is open, diode is closed. Okay, so here is a 50 plus 50, both 50 plus 50 plus 50, both 50. I mean 100 voltage fed to the source, fed to the source. So this is a method to you will going to charge the battery, So that is about the class B. Class B just same as it is for that one. Okay, once again I will going to tell you. So how to draw inductance. So inductance, then switch, then here what is that one? Here diode is used. So previously you have a boost converter, you are using this. This is a source, this is a load. So now it's a my turn. So it is a load, this is a source. So this is about the boost converter. Okay, class B converter, class B regeneration operations. So what is the mode of operations? This is a mode of operation, second mode of operation. So current is a flow in that one or not? Yes, that's why load to the source is a flow. That's why negative current, negative current.